Немного обо мне. Первый вопрос. Кто из вас был на вечере, когда я презентовал про AstraZeneca? Один человек. Отлично. Вот, 3 человек. Немного обо мне. То есть я учился в Бауманке, закончил Бауманский университет в 2009 году на специальном машиностроении, занимался подводными роботами. После Бауманки я попал в Южную Корею. Там я работал в Samsung Electronics более 4 лет. После этого я пошел в аспирантуру в Англии. Здесь я делал аспирантуру по искусственному интеллекту, работая с Natural Language Processing. И когда я закончил аспирантуру, я переехал в Швецию, где около 3 лет я работал в небольшой компании, стартап, которая занималась разработкой Decision Support Tools для патологоанатомов. Ну, например, если биопсия берется у пациента, да, то есть понять, если там рак, не рак и какой рак. Вот. И после этого я попал в AstraZeneca. Я думаю, вы все знаете эту компанию, да, которая делала прививки от ковида, и они тоже занимаются производством медицинских препаратов от рака, где проработал более 5 лет в Кембридже, в Англии. И, соответственно, там я был директором по Machine Learning и Artificial Intelligence. И в декабре прошлого года я перешел в Марс. Вот. И теперь я Senior Manager of GenAI Platforms в Марсе. Марс — это компания, которую вы знаете наверняка по сникерсам, Марсам, Твиксам. Кто не кушал шоколадки Марса? Все попробовали. Хороший вопрос, да. Не, я вам не принес, к сожалению, но в следующий раз, может быть, если будет у вас желание, могу принести. Марс — это компания, которая private company. Это семейный бизнес. Компания была основана в 1913 году. И компания, соответственно, все мы знаем, это confectionery, там, chocolates, да, там, Wrigley, жвачки. Большой тоже часть бизнеса. Второе — это еда. Это там долмина, соусы для пасты, Ben's Food, ну, то есть canned food, потом, соответственно, корм для животных, Whiskas, Pedigree. И вторая большая часть компании, которая на самом деле даже приносит больше половины прибыли по сравнению с едой, pet food, это Pet Care. Компания Mars владеет огромным количеством более 1400 ветеринарных клиник в Европе, в Америке. То есть они разрабатывают разные приложения, чтобы улучшить healthcare для животных. Вот, с этого, наверное, я начну немножко по-английски, потому что как бы с техническим русским у меня довольно плохо. Но как бы, если есть вопросы, задавайте на английском, на русском, как вам удобнее. И, конечно же, с 1 мая вас всех.
Коль, можно вопрос сразу?
Конечно.
Если в конце вопроса будет или потом?
Давайте перебивайте меня. У меня на самом деле немного слайдов, то есть как бы мы можем как бы больше вопрос-ответ. И как бы, ну, ввиду того, что многие из вас не были, когда я рассказывал про AstraZeneca, то есть я тоже там занимался похожими вещами, искусственный интеллект. Если есть какие-то вопросы по искусственному интеллекту, как бы, конечно, и, ну, да, то есть давайте сделать это неформально, то есть как вам удобнее. И еще, наверное, пару вопросов перед тем, как я начну. Какой у вас бэкграунд? У кого технический бэкграунд? У большинства. Кто связан с искусственным интеллектом? Половина. Кто из вас более on business side? Кто не поднял руку, чем вы занимаетесь?
Я связываю бизнес с разработкой, поэтому я сомневалась.
Еще кто-то, кто руку не поднял? Просто мне понять, что чем вы занимаетесь.
Ну, Data Science, ну, это тоже у нас такие,
Ну да.
То есть, как бы построить мост от моделей данных до продукта и value продукта. То есть это все как бы сфера.
Ну, отлично, значит, вы все довольно, я буду как бы assumption, да, вы все довольно технические, и как бы сегодня GenAI Platforms, Innovations, Challenges and Future. То есть GenAI Platforms, наверняка первый вопрос, что это такое, да? So I'm sure you heard about generative AI a lot, and let's maybe define what is generative artificial intelligence, right? And I think like if you kind of now it's almost everywhere, right? If you use ChatGPT or Copilot, then usually you text something, ask like prompt a question, for example, or ask for something to summarize a document, and then it will generate some summary. Yeah, so generative AI generates something like text, summary. It can generate an image. So there are a lot of like generative AI tools that text to image, right? Or even text to video. Like so you can just type something and a video will be generated. The same also you can generate text from images, and something like I presented last time at AstraZeneca, right? Also on generative AI. So the idea is like you have a biopsy, for example, it's an image, it's scanned, and then you generate a report, doctor report saying, okay, this is cancer, and the cancer is in the top left corner, or the area of cancer is this, it's great, something like that. So there's a lot of different ways, I would say different models on this generative artificial intelligence, and I think like now there are a lot of commercial tools, but also like for like more technical people, yeah, sometimes you would hear that there are generative models, right, and discriminative models, right? So if you have some data, you try to kind of, for example, classify your cats and dogs in that data, and you try to build like, kind of discrimination, like how you decide what's the border line, how you decide that, something new data belongs to, like, let's say cats or dogs, or you can kind of try to approximate the distribution of that data and, kind of be more kind of generative modeling. And then, once you kind of approximated that data, you can sample from the data. But, I think like, I would say these days, generative artificial intelligence is like a model, a system, something that can generate, text, video, images, and so on. How it started, right? It started as a research in academic labs. So I'm sure you heard about godfathers of AI, Yann LeCun, Jeffrey Hinton, Joshua Bengio, right? These guys, they've been in AI for a long time. And they started like as a kind of, heavy on more kind of foundational research. And so, for example, Yann LeCun developed one, LeNet, which kind of was a model, to kind of, let's say, for optical character recognition, right, to kind of detect what numbers are in image. For example, if you take an image of a car, you can detect, let's say, license plate, and then using these old networks, convolutional neural networks, to detect what numbers are there. So it started like with neural networks, a lot of research, then been a lot of, I would say, visibility for this kind of research through organizing challenges. So like, very famous like challenges for image recognition, and then like a huge data sets were curated and created, like ImageNet, with like, let's say millions of images classified in like 1,000 classes, and then more and more researchers started training models, publishing research, startups started investigating and using these, like, let's say, algorithms and models, and then, GPU also progressed a lot. More and more, I mean, you all know and follow, I'm sure, NVIDIA, how, I would say, much we progressed in producing graphical processing units. And recently, like, these guys were recognized with Nobel Prize, right, last year. And, we also heard, like, for example, one of big, let's say, problem they solved to predict properties of, like, three-dimensional properties of proteins with AlphaFold, for example, right? And, for example, in many pharma companies or biotech, now there is a lot of interest in predicting properties of like chemicals, how they, because predicting these properties, you can develop good drugs. You can understand how, let's say, these chemicals let's say, interact with proteins and so on, and see like if it can serve like for some medical purposes, like kill cancer or alternate some biological mechanism and so on. And the next step was, of course, for like several successful examples, commercial examples of GenAI, but I think like one of very outstanding one was ChatGPT. I'm sure like you already heard about it or used it, and it's really impressive how popular ChatGPT. I literally checked, I think yesterday, or like 400 daily or weekly users, 400 million, and you know, ChatGPT got to 100 million users in 2 months, and potentially like billions already used ChatGPT. So it's very impressive how these kind of tools became so popular. And you know, once these tools become popular, then many companies, governments, they start like looking into it and try to understand what's the impact, right? And imagine like I work like at AstraZeneca, right? I have like some sensitive data from let's say different patients, and then I start uploading it to ChatGPT and start asking questions, right? So it's kind of a bit of data privacy issue. Same for Mars, let's say, right? I have like Mars confidential data, which is potentially accessible by everyone at Mars, but if associates, I mean like people who work at Mars start using the data in, you know, ChatGPT, like, yeah, there's a kind of concerns there. Of course, like then, you know, companies usually, yeah, think about, okay, we can have a subscription for, you know, kind of sign up a contract with these companies, or like kind of buy maybe a small startup, right? Or, you know, or build ourselves, let's say, hire some people and build some kind of tools internal. But, you know, the thing is also always how much control and how much cost, yeah, is associated. Because like, you know, for example, tomorrow, as a company, you go to Microsoft or OpenAI and you sign a contract, right? You sign a contract, of course, you know, it's an agreement, right? But you don't know, you have no control over the data, you have no control of many things, what's happening. Of course, you can kind of, you know, go through it and even get a team, internal team, and kind of, you know, have more control. So there's like all kind of, I would say, different ways how you can leverage that technology, and it's more kind of multi-parameter optimization in terms of effort, right? In terms of technical effort, you know, do you need to build a team? Do you need to invest, like, you know, in buying these solutions, or even signing very pricey contracts with external, let's say, vendors? And also how much support you'll get if something goes wrong, you know, how much, let's say, it will take to fix it. So there are many kind of, I think, on the, of course, business side, but also on the technical side, how it works and what actually happens, you know, can we rely on it and so on. So, yeah, so since like, yeah, ChatGPT now, as I, you know, started like, you know, describing different companies, large enterprises, I mean, I worked at AstraZeneca, yeah, like GenAI was a very, you know, high priority project, and, you know, company-wide, let's say, initiative to understand what is GenAI, you know, make sure that there is governance about it, you know, all these ethics, data security, IT controls in place, and also make sure that, you know, there is a way to integrate GenAI and kind of get, you know, benefits of it. And, you know, benefits would be potentially making people more productive, right? So it's kind of potentially cut costs, or like unlock some new business. So if, like, you know, let's say a team or a department became more productive, you can potentially start working on more projects, right? Or you can, let's say, generate revenue, yeah, so potentially, let's say you can accelerate, you know, kind of access to, you know, different markets, or, you know. So I think, like, you know, there are plenty of opportunities. And one of idea, like, imagine if it's a corporation of like 100,000 people distributed across different countries, different locations. Yeah, every country has their regulations, kind of pool of talent, different data, also governance. You know, for example, you know, China, Russia, Western world, right? There are some firewalls around it, but, you know, many companies will work internationally. And then, like, also, as I mentioned, like, yeah, people in the company, how to empower them with GenAI tools. So that's I think a tendency, I would say, several last years. Like companies started establishing GenAI teams and building GenAI platforms. Yeah, and what is generative GenAI platform? So, for example, when I joined Mars, I didn't know much what is GenAI platform, but I was very excited to explore and understand more. And the goal of this GenAI platform is enable users to build potentially who are like on the technical side, and they can build themselves if they know like programming and have skills, or they can let's say work with some enabling units, IT teams within the company, or they can work with vendors, let's say, right? So you can build a platform, open some kind of API, open functionality, and hire some third-party vendors. It's very common, for example, at Mars as well. Then vendors develop, so kind of companies highlight the requirements and needs, and then vendors build tools, and then these tools they need to host them somewhere, right, and maintain. And okay, so GenAI platform is not only kind of to enable building, but also maintaining, sharing potentially. If I build a platform or like a tool, right, for my team, imagine in big companies, so like 5 teams building the same tool, right, and potentially not using because of a bit of different requirements. So one of idea to have enterprise GenAI platform, then you build tools which are reusable, and of course this kind of like single platform where you can go and find, so discover some tools. So maybe you don't need to build, communication in big companies is very challenging. So the idea you have this kind of GenAI platform where eventually you can discover, build, share GenAI tools, and these GenAI tools can be like from no code, yeah, ChatGPT like experience, so literally ChatGPT like experience asking something, but the benefit you can upload, let's say, your confidential data. So you don't go and vet and try to understand how like public ChatGPT works and what happens with your data or signing contracts. You can have your own tool, internal tool, where you have control of the data and you have more understanding what's happening there. So let's say associates, like people who work at the company, can use internal data safely. Then they can generate images. For example, in Mars, like let's say there are like company works on kind of promoting adoption of cats and dogs. So like different cats and dogs in shelters. And the idea is like, imagine you can take photos of that cat and dogs, but then you try to kind of let's say have a nice profile of that cat and dog, so someone on the internet can kind of find that cat and dog and say, oh, it's such a cute dog, I wanted to have, right, and let's say adopt it. And GenAI is very good in it, right? So you can take a few photos and then you can kind of augment these images and generate them in the way you want and put them on an adoption website, something like that, or marketing, right? There was a very nice advertisement with Jose Mourinho. So I don't know details how it happened, but my imagination is like, imagine if you want to make a promotion video with Jose Mourinho, potentially we need to call him, book like some video studio, invite like some, producer experts who, and, kind of make sure that it's all, let's say, aligned, and someone gets sick or some kind of, volcano erupts and then you cannot travel, so many things can happen. But instead you can sign a contract potentially with Jose Mourinho, something like that, yeah. Maybe ask that person kind of generate some videos, send it, and then you can use that material to generate, let's say, an advertisement in the way you want with like your script and so on, and then you can share it with the actor, sign off, and yeah. Is it something happening on TikTok, huh? I don't know. Yeah, something like that, right? It's, I think, very common, like...
But there's a lot of issues with that because the models are still training the works by other people.
Yeah.
And very often when we have some results, it's actually, we may not be even aware, but this is the results of exactly the same as the other ads were produced by people, and then it becomes like a legal issue.
Yeah, exactly, yeah. I'm not a legal expert. I don't know how it's resolved, but I think in terms of marketing, because companies, especially brand companies like Mars, imagine how much resources are invested in generating, producing all the material for a new chocolate or new region. And you potentially can use GenAI, like just type, like prompt a model, and that model will generate advertisement in terms of like promo, like text, but also images, brand guidelines, or and even videos. So yeah, this is like kind of the idea of generative platform. Any questions about the platform?
There's a lot of foundation model there, but usually foundation models define models trained on internet data and before involving the process of alignment and instructing. So foundation models are not sufficient for prompt engineering. That's also about here. So is it just like incomplete picture, or that's maybe
So the idea is like in practice, you're right. Most of models are kind of commercial, right? Like GPT, like series of models, or like some models like from Google or OpenAI, or whatever. Like kind of commercial models. But the idea is like, and of course it's more costly and more time-consuming and technical. You can take a foundation model and then fine-tune it on your data, right? And which is solving some specific task. And give you an example, maybe not from Mars, but from my previous work. We worked on different foundation models, imaging models. So a model was trained, let's say, on thousands, millions of histopathology images, and it was trained like for using some contrastive learning, right, without specific target. But then, let's say we used these foundation models to fine-tune on our small data set for a specific task. And the idea, was that you have like again approved, vetted foundation models. So of course you can take it from Hugging Face or somewhere. One kind of how to say idea of like let's say purpose of generative AI platform. Also to be a platform where you can choose models which were approved, vetted to some criteria to the company, like make sure that this model has right license, right? So you can use it for commercial purposes, right? That model was trained on some data which we kind of aware of, not something kind of legal.
And these models are not exclusively language models. It might be like
it can be any models. I mean even like for example, we use like GPT-4o model, which is multimodal, right? So of course ideally we want to have all modalities, but in practice I think it's mostly text and images, right? And text is quite easy, quite cheap, and I think it works quite well for different types. And in our data, since you started talking about these blogs, so idea is also generative AI, let's say platform. I don't know how like platforms built like in different companies, but you also would like to have connection to data, because imagine I have a model, I kind of fine tune or I generated something on my data, and I don't want to kind of like, let's say, have like completely disconnected, because I need to run somehow my models on the data. But also the challenge is like how you share that model. So for example, we work in the same company, I have access to some document and you don't have access to that document, right? And then I used some GPT-like model to generate something using my document. And then that output also has to be controlled, because it's also part of the data in terms of like access control, and I cannot share it, for example, with you. So what I'm saying, GenAI platform is not only about this AI stuff, but also think about access control, privacy data, and all this privilege, access management, and so on. So I would say it's quite heavy on security, because I think here quite quickly things can go in an uncontrolled way. So challenges, I already started talking about it. So GenAI is a fast-paced technology, changes very quickly. So I mean, these models are expensive, right? GPT like model, I think some Altman said like they spent, I don't know, hundreds, I don't know, millions or something of dollars, right? And potentially it was much more like even maybe billion of dollars, because once how you count it, like do you count like, let's say, because if you train a model, right, usually you have some data, you start training and it doesn't work, then you try kind of add more data potentially, and then it's an iterative process. And usually like when companies, or like what I've seen even in papers, like back to DeepSeek paper, they say, okay, the cost is like only one training run, right? But to get to that training run, how much training and effort and time they spent, right? So, and also on top of that, how many people, how many GPUs you use. So what I'm saying, like, it's expensive, especially once you do it the first time. But once you did it first time, it becomes cheaper. So on one point, like, the models are very expensive, but they're getting cheaper. And also, like, now we have these mini models, with much less parameters, which perform almost as good as bigger models, like GPT-4o, GPT-4o mini, or reasoning models like O1 or O1 mini, or 3 or 3 mini. And they perform for 90% of use cases, maybe an average company, as good as the big ones. So what I'm saying, like, you can't have a big models and then run some knowledge distillation or and have a smaller model which is as good as let's say a big model. And these days, like, it's one direction what's happening even on edge devices, right? You potentially can run like DeepSeek model R1, right, on your laptop, which is super impressive, right? So what I'm saying, like, this kind of progress happened very quickly, from like this $100 million, dollars to train just one model, to like having like quite easy to reuse models, quite small, and even that can run on quite small, I would say, hardware. Then of course, like, agents, I don't know, like, I'm sure like almost every one of you heard about agents. It's like, if last year people say was the year of GenAI, this year is agents. So, and it's on agenda of any company. So if you go to any event, or even like not technical, people talk about agents, some kind of, let's say, large language model based, conscious. Sometimes people even say conscious, or decision makers that can completely automate processes, right? And of course, there are different types of agents. And it's like also like Google introduced a agent-to-agent framework, right? And also now they have a consortium of different companies looking into like this kind of not only agents, but how these agents are orchestrated and communicate to each other and complete some tasks. Then there's like different protocols, like model context protocol, right? How these agents can talk to each other. Then regulation, of course, it's a huge, I would say, of course, like. It differs a lot across different regions, but it's also a huge discussion, right? In the States, in UK, in Europe, right? There are discussions happening on like how, what does it mean to be compliant for AI compliance, or like what kind of regulations do we need to make sure like we follow and like audit as well, right? Companies audit it, and they audit now what kind of AI tools they use and about GenAI. And one kind of, I would say, central part there is like human in the loop, right? If, especially imagine something like, I develop a tool which works perfectly, right? Which can, I don't know, diagnose cancer or no cancer, right? Can become an agent and without a human and just kind of, deploy it in a hospital, I don't know. But I think like these discussions are ongoing, right? And we are moving there. Then copilots, right? All these Microsoft Copilot, right? That can kind of record, let's say, transcribed, let's say, your meeting, and then generate some summary. I don't know. Who would say it works very well? You're happy with it?
From which perspective?
I mean, for your kind of.
Why not? I mean, you have summary. You can even send actions after this. I think it's okay.
Yeah. So for summary, it's okay, yeah?
Yeah.
Well, I mean, I agree. I kind of use it, and I'm sometimes very impressed. And actually, one idea also was like, imagine like to analyze all this transcript and kind of estimate how efficient some meetings are, or like how decisions were made and stuff like that. I think that's really interesting, right? Kind of area, and then I'm like, now I'm more careful what I say on camera, right? Because but then I think I was also thinking, like, if imagine you know that what you say is transcribed and then analyzed, maybe I would start injecting some words, right? So, I think.
And even facial expression.
Yeah.
Now it's kind of also tracked.
Yeah.
How a decision was made, very angry or very
Yeah.
happy. If not, maybe we should call to HR and check.
Yeah. Yeah.
Okay?
Yeah, that's very scary, I think, yeah, at least. And productivity, I'm also kind of more curious. So imagine, like, if a company makes people more productive, right? Now everyone has a copilot, right? Now you're 10% more productive. What does it mean, right? Does it mean, like, it's a great place to work for you now, or does it mean you'll get some extra task to do? Or, it means that 10% can go and do something else?
But it's still, if you talk about even the mails, it still can help a lot. If it can help you to sort like in buckets or create autoreplay for your emails.
Mm-hmm.
It increases effectiveness of your work. You can spend less time on doing some routine work and focus on more kind of more creative tasks. So it also can increase like happiness, because you don't do routine. If you're excited about work and you want to learn it, that I think you're safe. You just learn it and do more stuff, more interesting.
Yeah. I agree. I hope, like, most of leaders would look this way, but I think sometimes it's also kind of, an opportunity to kind of, to use it as a, I think like Microsoft or Google, right? I think these companies at some point, like, they invest in AI, but at some point they kind of also cut different costs. So I'm not sure, like, if it's, but I guess AI is, like, here to help. True. And modalities as well, right? So, we mentioned, like, text, images, and it can work with, different types of images, different types of text, voice, and so on, different languages. So it's a lot of progress. And I think, like, one of the challenges, like, at least I'm more talking maybe about, like, Mars or more enterprise GenAI platform, where you have some, imagine, models, kind of, let's say, GPT-4o or 1.3 mini, and you want to make that model useful for everyone. And by everyone, I mean like 100,000 associates, or like even 200 associates, right? Who work across different, let's say, departments, different job level, different job profiles, different background. Some of them may be like, more on finance, on business. Some of them more on data science, some on research. They all have some specific tasks, right? And how can you solve this? Of course, like, you can kind of take these models and fine-tune, for example, these models. For that, you need some data, right? Some kind of ground truth. So you need to kind of curate data or get it, which is some challenge. Of course, you can provide some examples. You can provide more like this, I would say common, like much easier ways that still kind of tune models without like changing the parameters of models, like retrieved augmented generation. So where you can, connect your large language models to some data, let's say 10, 20, whatever thousand of different PDF files and or a database, and then you're not querying, let's say, large language prompting. You're not prompting large language models directly, but then you can, let's say, retrieve relevant documents or parts of documents, and then you can extract that information. And once you generate output from LLM, you can use that context and that data that you extracted from very specific knowledge. So this is technically, I would say, much simpler than fine-tuning or retraining models. And it works quite well for many use cases. So from my experience, like, many tasks, for example, especially like, knowledge extraction, right? There are many documents sitting everywhere, and then, of course, if you put them maybe in SharePoint somewhere, if you're in one place, then you can use Copilot, something that works quite well with data search, maybe it uses, but like, imagine you have like different files sitting in different places, then, potentially you can, let's say, use some kind of platforms like from Microsoft, from Google, and build your retrieved augmented generation system where you kind of upload these documents, then you embed them in vectors, and then you calculate, let's say, similarity to like, you know, for example, your questions, and then you can retrieve right documents and, you know, use that right documents to, you know, to improve the answers. So this is like very common use case, like, you know, what we are facing. But, you know, again, as I mentioned, yeah, there's always like, okay, when do we decide that, you know, we develop this narrow, very specific use case, or, you know, we say, okay, we develop a feature which serves everyone, and yeah. So I think this is the challenge, and for example, for us, like, yeah, we kind of quite often spend a lot of time, and it's a combination of technical difficulty, of course, return on investment, in terms of how much time it saves, how much money it saves, whether it like opens new opportunities and so on, and you know how technical hard it is, what are the risks and so on. And I think, yeah, that's definitely a challenge. Agents, I mentioned, I'm still learning myself what are the agents. I'm still forming my opinion on what's these ones. But you know, let's say the agents which kind of we are looking into, think about like, you know, these large language models were trained on some kind of data which has a data cutoff. So it's like literally crawl internet until it's October 2023, then train your model, and then your model has a cutoff. It doesn't know anything after October 2023. So one way you can attach like so-called like a web crawler or like a web search agent, and then you ground that search with LLM. So it means when you search something, like, you know, run prompt, it's not only gives you output of large language models, it's also like crawl data on the web, and then it provides you kind of a weighted combined answer. So, you know, one is kind of this kind of web search agents, quite powerful. Then also like we call them natural language query agents, NLQ agents. So the idea is that LLMs are not good to work with numbers, with structured data. And they're trained on like, you know, text and so on. So for example, if you have Excel table, yeah, it would struggle. But then you can kind of build natural language query agent, which has also text to SQL part. So it means like, you know, for example, when you write a natural language, it could convert into like some SQL query. And then, let's say, your data must be already prepared in some database, it will query, and then like you can also generate, let's say, report or answer using that one. So this kind of agent also quite powerful, and we are looking into it.